Well, my flash presentation is about prospects and applications of machine learning in the area of seismic data processing and interpretation. At first, I want to say some words about seismic data. Seismic data are the results of land or marine seismic surveys. The basic idea of seismic survey is to send some acoustic signal into the Earth and then to record times and amplitudes of the returned echo. These records are called seismic traces. Seismic traces are grouped by some common features into the seismograms, and they are summarized in a special way to so-called seismic sections or seismic image of what is under the ground. There are two large stages of seismic data transformation. The first stage is called seismic data processing, and the second stage is called interpretation. During the first stage, processing stage, our raw seismic data are filtered from different types of noises, and at this stage is formed so-called seismic model or seismic image. During the second stage, the interpretation stage, the seismic model is transformed to so-called geological model, and some physical parameters such as density, porosity, permeability, and so on are estimated at this stage. The first task of seismic data processing is data filtering. I will tell you more about this stage in my next report. The second task of seismic data processing is a simulation of undesired signals. The variety of the methods of data fitting and data matching can be used in this stage to combine and to subtract the modeled undesigned signals from the raw data. The second application of machine learning in seismic data processing is data clustering. We use data clustering to tune parameters of standard procedure in each cluster separately. The greatest prospect for machine learning in seismic data processing is the automation of routine works of geophysics, and supervised machine learning can be used to spread small part of the manual data processing results onto all large seismic data set. Now about interpretation. The main goal of interpretation is to estimate geological parameters using seismic data, well data, and geologist knowledge and experience. Interpreters very often works with well data in addition to seismic data. And one of the most important tasks in interpretation is to combine well data and seismic data. Well data are the most accurate measurements, but they are very expensive, and so they are several times more expensive than seismic surveys. So one of the most important tasks of seismic data interpretation is to interpolate the information that well data contain using seismic data. And the final stage of interpretation is a so-called reservoir modeling. The main goal of this stage is to give advice where to drill a new well and to predict the volume of oil and gas that will be produced. That's all. Thank you and welcome to my stand.
Thank you very much. And